Hey folks, I'm going to do four problems from last night's homework. I'm going to show you what our homework should look like in our math notebook. And I also want to show you some pictures, on Rhino, right? So this guy right here is the same as number two. It's maybe upside down though, right? So on Rhino, you could just flip it upside down like that if you wanted. You can see the base is a circle, right? And then it's a cone. That's what we call these guys right here. If I want the surface area, it might make sense to unroll the surface. That's what this command's called. And I select it. And then what I want to do is I want to explode it, which means it's going to take the parts like the lateral area and the base is going to separate them. Okay, so I hit enter. And let's look here. I can grab I think I can grab the base. Ooh, it's kind of connected here. Oh, I think what I got to do is I got to explode it one more time here. So I grab now the base and I can move it off. So here's the base and then here's the lateral area. Can you imagine that? Like we picked up this flat piece of paper or aluminum or whatever and we rolled it into a cone. It would be, let's see if we can do the same with this guy. It would be that. No, it's not going to let me do it. I think it will. There, yeah, that's it right there. So it's like if I took this cone and I just exploded it. So you can see now the cone's base is like over here, right? And the lateral area doesn't have a base on it anymore. See how it's open? We can see right inside it. Okay, so this part right here is the lateral area, and then here's the base over here, right? So let me zoom back out. I want the lateral area first. I want this area right here. So let's just calculate it real quick. I get 233.5. Let's see if that's how it comes out to be. All right, so this is what your homework should look like, right? I mean, like we could probably find this answer on Google if we just typed in what's the area, lateral area of a cone with a height of 14 and a radius of 5. But this is what we're really trying to practice, like keeping our thoughts organized, not Google searching, right? So I go 1/2 perimeter times slant height on these guys. Anytime it comes to a point, this is the formula for lateral area. Now, if you look in the book, you might see something like this. Instead of perimeter, they might have circumference, 2 pi r, or they might have pi times diameter. That's the circumference of the circle. That's the same thing as the perimeter of the base, isn't it? It's just that the perimeter gets a special name since it's a circle. It's called the circumference. So right here, this would be a C if we're talking about a cone or a cylinder or something like that. And then this side is our slant height. So let me put a little L right there. That's what L stands for, the slant height or lateral height. Hey, I got to use Pythagorean theorem to find L, right? Because I've got a leg that's 14. I'm going to square that leg that's 14. I'm going to square the 5, and I'm going to set it equal to L squared. Now, maybe in class I said, let's kind of skip that initial setup and just put down 14 squared plus 5 squared. But I'm going to go a little bit slower in my video, all right? Here's what I want to replace the L with right there. So my L is going to be that square root of 14 squared plus 5 squared. Let's put that right there. Okay. And now let's see. Oh, wait, I got to plug a 5 right there. Okay. So, this is what I'm looking for in your homework. You don't even really have to write, an approximation here. If you want to just type it into McGraw-Hill, that's fine. But I'd like to see a drawing. I'd like to see some of this setup here. And now we're coming over here to Desmos, right? And I'd like to go to this guy, and then let's see if I can get all this on the screen at the same time. There we go. I need to go 2 or 1/2. I guess I'll start it out looking exactly like what my paper has here. 2 pi, and then I want to put a 5 in there, right? So I've got 2 pi times 5. I guess I could close my parenthesis off. I could open up a new parenthesis and I could go SQRT. That puts the square root down. And then I go 14 squared plus 5 squared. And my answer comes out to be 233.5. Wait a minute. Let's go back over to Rhino. Is that what Rhino had? 233.5. Look at that. Huh? Isn't that cool? All right. So that is my lateral area. Now I'm going to go for surface area. Okay. So maybe I'll put an approximation down, about 233.5, right? And oh, it's square meters. Square meters. Surface area, here we go. That's going to be equal to the lateral area plus the area of the base. See, I put a big capital B to say this is the base, the area of that circle. Somebody was asking me yesterday, well, I thought we used base for a rectangle. Like, here's the base of the rectangle, here's the height of the rectangle. You notice I use a lowercase b there? I know it might seem like no big deal, but yeah, we use the word base twice. This is the base, this is the height, right? And then over here, my circle, this is the base area. I think that's why they capitalized the capital B, because we want the base, the area of the base, right? All right, let's keep going. So the area of the base is pi r squared. So I got to go pi times 5 squared, right? That's the area of a circle. So I come back over to Desmos, and I just need to add. So I'm going to go plus pi 5 squared. 312.05. Okay, so let's see here, 312.05. So I put approximately equal to, I guess this is approximately equal to because I rounded that answer. 312, what was it again? 0.1, I guess, because we got to round up, right? 312.1. All right, square meters. Let's check it out on Rhino. All right, so I guess I got to do a few Control Z's to put my parts back together here. Now my object, I think, is one, how should we say this? Like see how the base is moving with the, let me zoom in on this guy. Okay, so I could rotate it and I could see, okay, the base is attached, right? Now I can calculate area of the whole thing. Now I'm doing surface area, right? So I get 312, wait a minute, that's what I got, 312.1, right? 312, look at that, 0.055. Rhino, whoever programmed this, knows these formulas, and it's applied, it's programmed in there for us, you know, but we're trying to practice our deductive reasoning skills. What do we see in this drawing? We're also trying to develop that as well. All right. Hey, let's do another one. Do not have a Rhino drawing for this guy, but sorry about that. The base is this equilateral triangle right here. So let me just draw the base out here because, man, that's kind of complicated in itself. We got this 9 here. Oh, look at that. It tells us the height. You know what? I think that's really just an approximation because that can't be an exact value. So right off the get-go, we're going to have to use their approximated height. They're just trying to save us some time. You know, you got a 30, 60, 90 triangle. If you're super advanced at the 30, 60, 90, you could find that this is 4.5 square root of 3. We're not going to get into that. That should be equal to or pretty close to 7.8, right? I can't resist. Let's go and test it out. And for those advanced people, hopefully this will make sense. 4.5 SQRT of 3, and look at that, 7 point. See how they rounded it, right? Okay. Well, anyways, so what's the area of this triangle? Well, it's 1/2 using their rounded number of 7.8 times the base, height times base in a triangle. See, we call the base of the triangle this segment length, right? So that's the area of the overall base. And there's 2 of them, of course. I don't know why I got suckered into doing the base first, you know, but I guess I'm kind of setting up surface area right now, right? It's going to be lateral area plus 2 bases. And I've just figured that out right here. I'm going to wait. I'm going to wait on doing the rest of this calculation. Let's go back and do lateral area. Okay. So what's my lateral area? Well, it's the perimeter of the base times the height. The height is 12. Okay. So I go, let's see, 9 plus 9 plus 9 is 27. So I get 27 times 12. Okay, that's my lateral area. All this stuff is going in here. Let's go and check it out. 27 times 12. 27 times 12 is 324. Okay, let's see if I can get this on the screen for you. So we got 324. All right, so let's put that in here. That is 324. And then down here, I go 324 plus 2 of these bases right here, right? That's going to go right there. See how my homework, yeah, I wrote down 324 right here, approximately equal to, and it is square centimeters, right? But, I'm not maybe putting an approximation in here because I'm about ready to do it on Desmos, right? So we got that 324 number. I'm just going to add plus 2 times, oh boy, where'd those numbers go? Okay, there they are. 2 times 7.8 times, oh wait, 1/2. 1/2. I guess the 2 times 1/2, I could have canceled those out, couldn't I? And then I got 7.8. 7.8. Now I'm a little nervous. Did it multiply 1/2 times 7.8? I think it did. Might want to just put a times in there, but it did, didn't it? Nothing changed right there. And then I go times 9, and you could put those in parentheses if you want. So I got 394.2. So overall, I've got 394.2. 394.2. This is what our work should look like. Now, if you're like, man, I have a hard time putting these drawings down, I get it. It is difficult. But one thing you can focus on is draw the base and then make some lines that are parallel to each other. And so look, I made those lines parallel. Now I'm going to try to match this one up right here, make it parallel to that one right there. And it kind of starts looking like it. If you want to put some hidden lines in there, see how they have that dashed line means a hidden line right there. And then we got another hidden line there and another hidden line there, right? And you put 12 there, 9 there. Might be valuable just to kind of practice your drawing skills too. See if you can get a drawing down. Hey, thanks for watching my video. Keep watching, okay? If you need some more help. Number 7 is another one I'm going to do. So lateral area is perimeter times height. Let's go back. That was the same for this lateral area as well. Perimeter of the base times the height. Perimeter was 9 plus 9 plus 9, and then the height was 12. Even though it doesn't look like it's like this, it's not sitting on this base. A lot of times they'll have the drawing sitting on the base like this one is, right? See, the base is a circle. So I need to know what the perimeter of the base is, which is the diameter times pi. That's our formula for pi times diameter, right? That's the circumference formula for a circle. And then we take that times the height. So really I get 120 pi. See, if they ask us to put an exact answer in, that's the exact answer. If they want an approximation, rounded to the nearest whatever, well, let's put 120 pi in, 120 pi. So 376.99. So I guess I better round to 377. So 377, and that would be in square inches. Okay, here comes the surface area. Surface area is going to be that number, 377 square inches plus 2 bases, 2 pi r squareds, right? Because the area of the base is going to be that circle. The radius is 6. So I get the base being pi times 6 squared. That's 36 pi, right? Because 6 squared is 36. So I get 2 of those. So plus 2, 36 pi's. Okay, this is the way I'd kind of make my work look. I jump over here and I go, let's see. I'm trying to make it look like, where can I put this here? Right here. All right, don't move. Okay, plus 2 times 36 pi, right? And if you want to make it look exactly like what I got on my paper, right? The same thing right there, right? So that comes out to be 603. So we put over here, okay, all of this stuff equals approximately 603 something, right? What was that number again? 0.2. Okay, so 0.2. See how there's an 8 there, and 1, so I got to round that 1 up, right? Oh man, I really hope I'm making this clear. I'm not asking to write down a million different things. I am asking to put a little drawing down and then, mark up your drawing and all that kind of stuff. So this one's a little bit tougher because we got an equal or a regular polygon. So 1, 2, 3, 4, 5, 6 sides, right? So I'm going to try to draw a little hexagon over here. Might not look pretty, but this is what I would have on my homework. So I'm just trying to show you, what it looks like. And so it says one of the sides is 8. So I come in here, I put my radius here, I put my radius over there. I know that's a 60-degree angle because I've got 360 divided by 6 is 60 degrees. I'm going to cut that right there. in half. So let me kind of zoom in on this as this gets a little bit more complicated, doesn't it? So I go like this. I drop it right down there. That means that that's my apothem, right? That's a 30-degree angle. This is 4 right down here to go from the short leg to the long leg. We multiply by the square root of 3. So the apothem is 4 square root of 3, right? All right. Now to find the area of the base, I go, let's see, what is it? 1/2 perimeter times apothem, right? So I've got 8 times 6, because there's an 8 here, 8 there, 8 there, 8 there, 8 there. So I've got 8 there. Sounded like I ate at that restaurant or something like, hey, 8 there. So there's 6 8s going around. That's 48. And then the apothem is 4 square root of 3. So I put that down. And now, I'm going to jam all that into decimals. That's my base area. Now, what is the perimeter? Let's go back. I kind of got ahead of myself again. I got all excited about that base. The lateral area, since it comes to a point, is going to be 1/2 perimeter times the slant height. Oh, thank goodness they told us the slant height, so we don't have to use Pythagorean theorem. So we just calculated the perimeter over here, didn't we? Didn't we say the perimeter is 48, right? There's the perimeter. So I'm going to put 48 in here, and then the slant height is 20. Half of 4, we won't bother with it. Let's do it in our heads. So I go half of 48 times 20, half times 48 times 20, and we get 480, right? Okay, so jump it back over here. That's my lateral area, 480. Now I need to add a base to get my surface area. So I go 480. Let's see, that was in square inches. And then I'm going to add that stuff right over here. This is exactly what I would do, and so I just need to go plus, and we're going to try to add that half 48. So I go half 48 times 4 square root of 3. So times 4, SQRT, 3. And I get 646.3. 646.3 is what that comes out to be. 646.3 square inches. Woo! Okay. Hey, there were 4 homework problems. I think I just did 4 homework problems. And in my video 2, I'm going to do one of the extension problems for those people doing, kind of a little bit more advanced work. If your homework looks like this on all 12 problems, I don't want you to spend any more time in that homework assignment. I want you to try the extension assignment. Thanks, everybody.